I'm the Executive Director of SAMCRA, which is the South African Metal Cladding and Roofing Association, and we concentrate on all matters to do with self-supporting metal cladding. So today's subject's a little off the mark, but it has quite a big impact on the performance of cladding on buildings.
Great. So I think we are going to have people joining us as we go along. Just a little bit of housekeeping. If you have a question, please pop it in the chat. If you have your camera on, I may call on you and think that you have a question to ask. So if you prefer not to be called on, just leave your camera off. Dennis, can you kick us off? What are the primary functions of Hailguards?
Well, the first one, of course, is very obvious, and that's keeping the hail out of the gutters so that they can perform and get the rainwater off the roof and into the downwater pipes. The second one is protection of the outlets, because often outlets get gummed up and those horrible wire things that they put in them don't really work, and we'll chat about that a bit later. And of course, they provide a very good barrier against windblown debris. It's amazing when I've got on roofs, on shopping centres and that, what you find stuck in the downpipes on those roofs, from 1 litre plastic bottles to plastic wrap and everything in between. But the most important thing is the first intent of a Hailguard is not to be a walkway, and that needs to be considered when we come to the design, and we'll chat about that in a few minutes. Now, when it comes to hail, there's two types of hail. You get large hail, and that is defined as anything bigger than 20 millimeter diameter. And that type of hail does a lot of structural damage, particularly to fragile things like glass panes, weathered, translucent sheeting, and that. But the main thing is they normally are fairly short duration, and if they do accumulate in the gutter, because of their size, it's like a bunch of grapes, and there's a lot of cavities between them, which allows drainage to take place. Now, if you look at our first visual, this was a shopping centre out in Klerksdorp, and you can see where the downpipes are, because that's where the black holes occur. But you can see on a flat roof, the small hail accumulates, and it accumulates very rapidly. And the problem with small hail is it doesn't normally, it's normally preceded by a brief or perhaps quite an extensive shower of rain. So the first bits of hail that start to fall on the roof end up being washed into the gutter and block up the gutter and affect its performance. And if you look at the next, that little insert, please, Denise. This was a roof in Klerksdorp in 2014, November 2014, and they had two very heavy falls of fine hail in a single afternoon. And you can see there that it ultimately ended up being around 200-300 millimeters deep. That was a guy standing on the ground, but on areas of the roof, and particularly the main roof of the shopping center, we had 200 to 300 millimeters of rain accumulate. The other thing is that hail doesn't tend to slide off a roof until you start to get around a slope of 26 degrees. So anything less than 26 degrees, it's just going to sit on that roof. And the problem again arises there is that it freezes. It freezes rather rapidly, but particularly with an insulated roof, you get that layer almost like what's underneath a glacier. The interface layer between the hail and the cladding is where the first lot of melt takes place, and you then get flooding of the pans. And if you would like to, there we go. And of course, with conventional pierce fix, that's your corrugated iron and your IBR profiles, once the depth of water in the pan gets to the lip of the side lap, a capillary siphon is developed and moisture gets taken into the interior of the building. And effectively, if you look at that bottom picture, to create a capillary break, you need a 1 millimeter gap and literally a dent in the top knuckle of that one ribbon that will solve your problem. So to overcome this problem, we recommend that all side laps are sealed, and there's the details of what we recommend you should use for sealing them. And then, of course, the diagram on the bottom right-hand side is a typical conceal fix, which has a built-in capillary break. But the problem also arises, particularly if you've got a bit of a cantilever or an exposed area underneath the gutter, that an ice dam will form on the edge of the cladding where it's much colder than where the insulation is coming into play, and that in itself can cause even the capillary break on a conceal fix profile to be jumped. And on this particular building, it did have in one section, well, the whole roof was conceal fix, but in one section it didn't have gutters. It had a free overhanging edge into the car park, and what happened was an ice dam formed on the end of the sheets, and it caused a blockage, and the roof started to leak from the gutter back up into its ridge. So yes, in extreme conditions you can challenge the capillary break on a conceal fix profile. Now, the next thing that is always very important to remember are that very fine hail tends to form in drifts. And this diagram gives you an example of hail that has drifted behind parapets or against walls where a building protrudes. If you've got a single-story roof adjacent to a double-story building, it all tends to get in there. And of course, that gutter becomes dysfunctional. And again, you run the risk on that very edge of that sheet of an ice dam forming with the hail. And then please note that if the gutter doesn't have a return, now I'm in the top left-hand corner there, please make sure the counter flash into a gutter with a normal upstand, the lip is in, not out. It's vitally important that you create a capillary break at that interface. And then, of course, the other thing you don't do is when you have the circumstance with a gutter abutting a wall is use a torch on counter flash or one of these paint on pop and lop types of things. And the reason for that is that counter flash and the brickwork or the building work that it's fixed into is pretty inert from a temperature point of view, whereas your gutter is moving around thermally. And if you do tie those surfaces all together, with thermal movement in the gutter, it's going to rip the torch on or the pop and lock off the surface and create a leak point between the upper edge of the gutter and where the pop and lock or the torch on membrane is attached. Right, and let's talk a little bit about the location. Denise? There we go. In the 1960s and 1970s, most Hailguards comprised what basically can be described as a hinge, where you had a metal bar frame with some mesh tied to it, and it fitted into the gutter like that. But unfortunately, that particular type of Hailguard has a lot of comebacks. First of all, it becomes very popular for bridegrooms, so they tend to walk off the roof. But more importantly, if we have a look at the next item, Denise, is you've got to be very careful. No, you go on. Okay, that's fine. You've got to be very careful because if you get a gutter getting up to the top, to its brim, you're going to get flow back into the building. And that again happens when you get ice with that hinge type Hailguard. And of course, as the bottom right-hand image shows, if you've got blanket type insulation squashed in there and the contractor got a bit hanging down into the gutter, that's going to act as a wick and draw moisture up, not only from hail, but of course, if you have a pretty full gutter. And that image is where was the first purlin up on a roof where it wicked and it corroded from the inside out. Now, if we go to the next slide, that's a classic case of where something was put in on the left-hand side there to cover the gut, to protect the outlet from the gutter into the downpipe. And of course, it got clogged up, and they do get clogged up very, very quickly. That's the kind of blockage you get. So that's one of the reasons we don't recommend you have those wire basket things stuck in the downpipe outlet. Far rather keep everything out of the gutter if you can. And the image on the right was one solution that's available, which is like a king-size bottle brush that you put in to keep things out of the gutter. But of course, it takes up a hell of a lot of your gutter capacity.
That won't work. We use that as a fish tank filtration element, and trust me, it'll fill up with gunk very quickly.
Oh, I'm sure it will. Yeah, and you could, if you consider the dust that accumulates on a roof inland during the winter months, and then we get a heavy dew point, you've got a fair concentration of mud, and we've had experience where the hole, the outlet into the downpipe, if it's not via a cone, so you just have a straightforward hole down into the downpipe, that actually blocks up with dust and cements across, and you actually get plants growing in it. So it's, keep the stuff out as much as you can, if you can.
If I could just ask, if any of you have a question that you'd like to say, just for the benefit of the rest of us that are here, if you speak, could you perhaps just identify yourself, say, hi, I'm so-and-so from wherever, just so that there's not a like disembodied ghost voice floating in the ether. Dennis, I've got a question just about building standards. You mentioned when we were chatting earlier about the Australian building codes, that they were going to be changing their building codes. Are the South African national building regulations going to be reviewed as it relates to the topic of today?
Denise, thanks for reminding me about that. One thing I forgot to mention when I was talking about the accumulation of small hail on a roof, in 2015, they had a very severe hailstorm in Sydney, Australia, where they had a lot of ice packing, or hail that turned to ice packing on the roof, and they had a number of failures, not only of the cladding, but of some of the structures. And from that, they have reviewed their design codes and are busy upgrading them. Fortunately, the South African loading code 10160 part 2, it calls for under construction 0.75 kilopascals UDL, and that will accommodate up to about 80 to 100 millimeters depth of hail, because fine hail packed, the mass of that varies between 500 and 600 kilograms a cubic meter. So it can become quite substantial, and particularly where you've got a half sheet with a side flashing, where you could buckle the rib of the sheet there. So thanks for reminding me of that.
Super. Thanks, Dennis.
Just one more question, Denise, related to that for Dennis. You said that it's possible for hail to drift. Do these codes account for the overload that happens at parapets due to drift?
The South African one, 10160 part 2, and I think it's clause 9.4, somewhere there, they tell you that they have allowed in the UDL for 60 millimeters of hail. So anything thicker than 60, and yep, it happens, maybe your 1 in 50 year storm, but it does happen. And then another thing that is often overlooked, because on a pierce fix roof or on even a conceal fix roof, we've got very deep hail and the capillary break has been breached and it starts to leak inside the building. People get up on the roof and sweep the hail off. So in addition to the hail, the mass of the hail, you've got the mass of the people on the roof sweeping it off. And again, you can get a concentration of load. So good question, Amanda.
Super. questions, just a reminder, you're welcome to pop your questions in the chat. There will be an opportunity after Dennis has done his presentation for any other questions to come up related to Hailguards or anything related to roofing or cladding, or Emmanuel's also here to answer any technical questions related to structural steel. So Dennis, continue and let me know when you need me to change slides.
Okay, let's move to the next one, because now we're going to be looking at the design considerations. And the best place to get your Hailguard is that broken dotted red line. You've kept the hail out of the gutter, you've kept the debris out of the gutter, or the debris, I should say, out of the gutter, and you've avoided the risk of flooding the gutter if you have that old-fashioned hinge type Hailguard in there. You've got everything above the surface of the cladding, and that's where you want the liquids to be, so that they then get into the troughs of the cladding and drain into a clear gutter. Right, so then if we go to the next one, here is an example that comes from New Zealand, where this is the type of Hailguard they've used there. And if you look at the image on the right there enlarged, this is actually a plastic mesh, and it's clipped on with that metal button, I guess is the best way of describing it, that's got spikes that grip the plastic. The problem with that particular type of Hailguard, and that's a concealed fixed profile you can see there, is that the end of the rib is open. And once again, you run the risk of stuff getting into that opening and flooding the building and skipping the gutter altogether. Okay, go on to the next one. And this is a suggested one. It's not a definitive detail, but it's to make people think when they're designing these things what you need to do. Because you can't have your Hailguards installed, if you're going to have them above the surface of the cladding, you can't have them installed until the cladding's installed. And you can't have, no, what are you doing, Denise? Can we go back to that? That's it, thank you. And then you can't have them installed on stalks. I mean, you could have a beam spanning, or a piece of angle spanning across your gutter with some upstands that you attach your Hailguards to. But then you run the very real risk of damaging the sheets when they're being installed, the undersurface of the sheets, the protective coating on the undersurface of the sheets. And that could present a whole lot of corrosion problems further down the line. And then the other thing is that you need to avoid getting interface within the surface of the gutter, because if you've got a metallic surface touching the surface of the gutter, you're creating a crevice, and crevice corrosion is very aggressive and will very rapidly strip your zinc coating from both the gutter and whatever you've got standing in the gutter, not to mention the risk of anything standing in the gutter blocking the flow of water and any debris that has got in there getting into the downpipe outlets. And of course, the other thing is that when you're playing around with your Hailguards, you need to make sure that they are of coating or material that's not going to set up a bimetallic cell. Because bimetal corrosion is a great problem on modern roofs. Denise, you had a question there?
Yeah, I just wanted to find out, where can people that are attending this webinar, where can they find out more information on bimetal corrosion?
As part of the upload for this question and answer session, I will include two tables which have been included in the new SANS 10400L roofs. One gives you a table of what metals you can have in direct contact with one another, and the other one is what you can have where you drain from one type of surface onto another type of surface. And it's very important for people to realize that if you've got a galvanized roof, you can't put anything other than galvanized on it. Otherwise, you're going to have problems with either inert or drip stop corrosion or bimetal corrosion. And when we discuss gutters in a couple of weeks' time, we'll show you some examples of what happens if you get the wrong materials in the wrong place.
Thanks for that, Dennis.
All right, so if we could go to the next one. As I say, this was a schematic of the type of design you can use. This is a second one because, sorry, if we could just go back to that previous slide, Denise. Please note that that gutter has, with that sort of gutter and that type of Hailguard that is positively fixed to both sets of sheeting, you can't have sheet lengths in excess of 15 meters. Otherwise, thermal movement will cause that thing to flex, and it'll crack. You'll develop what we call it, a fatigue crack within the metal of your mesh, assuming, of course, you're using a metal mesh. And then if we go on to the next one, this is an alternative to that. And what you do is you have these little channel cuttings that you attach to the rib of the cladding. And you can have them at every 1.5 meters, 1.8 up to 1.8 meters apart, depending on what mesh you're using. And then you bend your mesh to look very much like a ridge flash. And you just let it float on top of the channels, and the sheets can move underneath quite independently without any risk of interference with the thermal movement and the Hailguard or the Hailguard supports. Right, next one. Now, when it comes to the materials for Hailguards, you have to look at your durability, and they can be anything from plastic mesh, as I spoke about earlier, to some chicken mesh laid on the top there. The big issue is, and you must not forget, Hailguards have got to be removable to facilitate the cleaning of the gutter and servicing of the gutter itself. Its surface from time to time is going to need to be recoated. So you need to be able to take these Hailguards off. So that's something you need to consider. And then if you look at the materials, the most common one is expanded metal. And Mentis make a product called Mentex 99, which they claim is specifically for Hailguards, and it's got an aperture of 13 by 38 diamond in it. The problem is, expanded metal, you cannot hot dip galvanize. So you're stuck with it either painted, or in the case of the Mentex product, they punch it out of pre-galvanized material, 1.6 pre-galvanized material. Now there's a correlation between the size of the apertures and the thickness of the coating as to how long you will get cathodic protection on the cut edges of that diamond mesh or expanded mesh, whichever you want to call it, before you get an onset of rust. And in my opinion, expanded mesh rolled from or manufactured from pre-galv is going to rust pretty quickly, and you'll probably find that you only have a life of 5 to 8 years in a corrosive environment before that mesh has rusted completely and is starting to attack your metallic coatings on your cladding. So if you're going to use expanded mesh, you're going to have to give it a pretty good paint system, and the old gungy black tar stuff that they used to put on is pretty effective there. Another material that you can use for it is woven wire mesh with apertures up to around about 20-30 millimeter diameter, and that mesh is rolled, or should I say woven, from 1.6 millimeter diameter galvanized wire. Now again, anything that is pre-galvanized has a coating at best of Z275, which would amount to around 19 microns of coating. And by comparison, a hot dipped galvanized surface has between 60 and 80 microns. So it gives you some idea of how thin that coating is, and there your expected life in a moderately corrosive environment would be 10-12 years before it started to rust. And one thing that is greatly overlooked, everyone talks about the corrosivity of the environment and, oh, it's a benign, it's an industrial, mild industrial area, or it's a shopping center or whatever. If you are downwind from a major freeway and the R21 is one, and I forget the number, that goes out to Mpumalanga. There we're picking up enormous amounts of corrosion on metallic surfaces of cladding. So if you're anywhere in Gauteng, and if you're out in Mpumalanga near the coal fields, you really need to treat that as a severely corrosive environment. And then just finally, alternatives that you could consider are these expanded walkways. Most of them are aluminium, so they're pretty expensive. And again, you can't put them on a galvanized surface. Or the yellow ones that are shown there are fiberglass. They are very durable, but unfortunately expensive. But if you needed a walkway, particularly if you've got photovoltaic panels on the roof and you're going to have walkways, you can consider trying to go and get the walkway for the bottom access of the panel battery and the gutter Hailguard all in one. And that's it, class.
Yeah, just one question from me. I know that you mentioned a little bit, maybe I missed this part, so forgive me if you've already answered this question, Dennis. Are there any companies that supply or manufacture ready-made Hailguards?
No, I'm not aware of any company. Most of them are made up to the engineer's design or the roofing contractor's design. He's responsible for them.
Okay. Right. I'm just going to dip into the chat and see that we've got lots of questions going there, and I've been ignoring you. Sorry, it's because I was running the presentation. So Dennis, just a question from David Freemy. If I've got that wrong, sorry if I'm butchering your name. SAISC states an accessible roofs have, unaccessible roofs have 25 to 30 kilograms per square meter of live load. What is your opinion on hail floating on the water, full water gutters? Will it flow if the gutter of the surface? Okay, hold on a second. Can you see the chat, Dennis?
Yeah,
the chat. Okay, just at the
sorry,
bottom.
Denise.
Yes.
I think that
can you see?
Yes, I can see. Okay. Yes, and the comments are, I think, different. So I think the first comment was he's just telling us that the SANS requires 25 to 30 kilograms square meter of live load. I think that must be in response to the earlier comments about drift and load. And then
if I may just interrupt there.
Yes.
It's not 25 kilograms per square meter when it comes to cladding. It's actually 75. And if the area is less than, I think, 3 square meters or 10 square meters, it's one of those variables you can have to help. So that's why the cladding often stands up very well.
Yes.
But you could have a problem with the structure underneath, the purlins, particularly if they're stretched to the limit of them buckling, because there, yes, the structural engineer probably has only considered the 25 and not the 75 construction requirement for cladding.
That's 100% correct.
Okay, thanks for that, David. Did you have any other questions there that you wanted to just ask Dennis, David, while we've got you live?
When we, okay, so let me just introduce myself, David Freem, MD of DFCE. We are the resident engineers for a lot of the Gauteng and Cape Town shopping centres. Now, under my instruction, we've been throwing out all the Hailguards on all the shopping centres because they, as you were saying, Dennis, they're haphazardly removed and put back, and they just become a complete clutter, and the birds nest in them, and there's a big problem with them. So we've just found that there's a culture of non-maintenance in our country. We know this. So what we find is that in theory, these things work, but in practice, they don't. So what we've been doing of late is opting for oversized overflows on our buildings. So in other words, the hail, if it does fall, we choose to throw the top half of our water out of the building, including the hail. And that's working very successfully on a number of malls. Do you have any comments on hail floating on the water within the gutter? That's my question.
Okay, well, that is something that we will be addressing, as I said, later in the year when we discuss the design of gutters themselves. And yes, it is very good that you have got an overflow or a weir at the end of your gutters to allow it to go out. and hail will float to an extent.
Correct.
But then you must remember, like an iceberg, 2/3 of it is below the surface. So unless your wear is pretty substantial at the end, it's going to accumulate against the plate that creates the wear at the gutter end, and you could still then get a flooded gutter.
Yeah, just to give you an idea, the sizes we are putting in are 600 wide and 300 deep, because we're talking about big internal gutters. And we've had endless issues with, for example, for even pluvia outlets, they often freeze up as well. So we have the, let's call it, if all else fails, throw it out the side kind of philosophy. Do you agree with that?
Yes, I do. That having a spigot that goes out sideways is quite an advantage if you can discharge off a shopping centre that way, and hopefully not onto the visitors to the shopping centre. But
yeah, we know this, but we'd rather have that than it affecting the retail on the inside from a client's perspective, but obviously not from a
tongue-in-cheek. The one thing though is that yes, you will then need your very much oversized gutter, because the flow in a wide shallow gutter is not as good as in a deep narrow gutter. And again, we will address that in a couple of weeks' time when we discuss gutter design. But what you're doing, I think, is smart.
Thank you.
Because the other thing is, the wider that gutter, the less likely it is to become a trap, because the wind will take stuff out of a wide gutter. It doesn't take it out of a narrow gutter.
And can I please just leave a thought in all the audience members' minds? If you are speccing a gutter on a shopping center that's shallower than 250 mils, you need to have your head read. That's the end of my comment. Thank you.
Oh, shots fired. Now I'm going to be like singing in the rain with my umbrella as I'm walking past shopping centers. Matthew, you have a question?
One final comment there, David, and I would appreciate you SMSing me or emailing me your contact details, because there's a number of issues in shopping centers I would like to discuss with you. But the one thing when you get a very big, wide, shallow gutter is that it then becomes susceptible to ponding, which in its own right presents all sorts of problems.
Yeah, so any technical questions or comments, or people that need to get in touch with Dennis, his email is dennis@saisc.co.za. Right, Matthew, do you want to maybe just elaborate on your question regarding powder coating? I think I missed it earlier on. I just want you to maybe give it a little bit of context,
Sure.
if you're happy to ask.
Can you hear me?
Yes, we can hear you.
Okay, so I'm an architect from SVA International. We do a lot of all kinds of buildings. I'm actually busy with a building now that has gutters that I was thinking about. And it occurred to me you could get the pre-gal punched and then just powder coat it like we do our Clearview fencing. Not that I recommend Clearview, it's just one of many, but they do a PVC coating, or you could do a powder coating on the mesh once it's been cut and shaped to size. Is that feasible, besides the extra cost, obviously?
That's a costly alternative. Yes, you can. There's no harm in doing that, but I think you need to compare the cost between an aluminium mesh and a powder coated steel mesh.
But with aluminium, aren't you going to get white death, the dreaded white death corrosion? Because if that touches metal, you get bimetallic corrosion too. You'd have to powder coat the aluminium as well.
That's the bimetal corrosion that I was talking about earlier, and therefore you would have to use
stainless connections.
No, please don't go and do that, because you can overkill when it comes to corrosion. What you need to do is isolate it, and if you look at the details that we flashed up of some of the designs, where you use that little F10 or S10 side bracket which has a gasket in it, and then you attach your aluminium to that. As long as that side bracket is made from an aluminium alloyed coated material or painted coated material, you won't need to worry about bimetal corrosion.
Are those brackets designed for hidden fix only, or do they work on IBR as well?
No, you could use them on IBR. You'd have to ask the manufacturer to make a slightly bigger version for you.
You said is it F for Freddy or S for sugar? F10.
Depends who you buy them from. The different profilers who sell those things for their concealed fix will call it an F1 if you're buying from, I think GRS called it an F, and SAFA will call it an S, but it's the same thing. And there are other people who manufacture them that you can buy from as well.
Okay. While I've got you, I just brought up the fiber grade specs. The smallest spec they have is something called air mesh, multi-grid or micro mesh, which are 1/2 inch, 25 point. That's 13 mils. Call it 13 mil penetration. Is that sufficient for Hailguard?
I would tend to go up. I would not tend to go down. And the reason I say that, it depends. If you have a very close mesh and you have a very long roof slope, the flow of water that is coming down there, the speed of that water, if it hits that type of Hailguard and can't get underneath it, it's going to almost be like a solid plate. So
you want some hail to go through, but not all of it.
You want a little bit to go through. You want an opening of some description there. And I wouldn't go for a small, if you're going to use a grid, I would like these walkways, I would be quite happy with a 30 square or a 40 square. I wouldn't go to
so 1 inch is even, that's plenty.
Yeah, 25 aperture is fine.
Okay, but then the load profile, according to Fibergrate, is between 4 and 6 pounds per square feet, which works out to
4 pounds. Oh, okay.
Yeah, so it's about two times now. It's about 20 to 30 kgs per square.
No, not per square. How much per square? You say how many kgs?
Let's say best case 6 pounds per square foot times by
okay, so that
times about 11. So
yeah, you'd be
about
around
3.
20.
Yeah, 30 best case. You're still only at 30 kgs a square, which is nothing close to that 75.
Yeah, all it means is you're going to have a hell of a lot of contact points where you attach it to the cladding to carry the load, because you can't go and put heavy loads on the end of the cantilever.
Sorry, are you that 75 kgs is the load applied to the sheet or to the Hailguard?
Irrespective. If you've got to be very careful.
Because you'll never get a UDL if you're trying to transfer the load from the grating to the sheeting with brackets. It's going to become a point load.
No, you won't. It won't be a point load. If you have brackets at 600 to 700 millimeter centers, you could consider that as a UDL.
All right,
you're going to be very careful when it becomes a cantilever as to what's going to happen there, because most cladding has a maximum cantilever between 150 and 200 millimeters. So you would have to take your support point. You'd have to have a wider walkway and take your support point where you're over a purlin. The first purlin.
Yeah, I mean, that's fine. I mean, but my concern is I don't know of any fiber grating better than Fibergrate, which is made by Stonecore, and their maximum load is 30, 40 k's per square. So is that sufficient for a Hailguard?
Yes, because don't forget, I mentioned that hail weighs between 500 and 600 kilograms a cubic meter.
Okay, fair enough. All right, cool.
Not per square meter.
So then
you're down to about
super.
25,
Thanks.
30.
Thanks so much for that, Matthew. If you've got any extra questions, you can always just pop them over to Dennis in a mail. I see that David Haynes has his camera on. I'm sure he's just waiting to ask a question. David?
Hello, everyone. David Haynes from DRA here. Dennis, thanks. This has been a great talk. I do notice that all of your Hailguards shown go over the top of the profile, so there is an opening below them. Now, you've just spoken to Matthew about it being desirable that you allow the hail to go below the Hailguard in that instance. You right at the start of your presentation, there was a picture of the gutter that are blocked up with fine hail. I think it was in Clarksdorp or somewhere like that.
Correct.
So even though you are putting on these Hailguards or suggesting we put on these Hailguards, there is a slight risk that there is going to be that kind of hail and that kind of blockage of the gutters.
Okay, I think the point you're missing there, David, is first of all, those gutters did not have Hailguards. So that was why they clogged up fairly quickly. Secondly, rather have the hail dam up on the sheeting than in your gutters. And if you can just avoid getting an ice dam on the end, getting a bit of hail into that void which is the depth of the rip. So on most profiles, that's 35 to, well, it could be anywhere from 25 to 45 millimeter opening. That hail will soon build up against that and create a block, if you know what I mean, or a wall. And the water flows underneath it because it's thawing out from the warm cladding that has been insulated.
Right.
You've got a much warmer surface there, and it tends to melt much quicker there than if you don't have insulation under it.
Okay, and then just one final comment as far as the other David is concerned in his discussions regarding the spigot outlet. It would then go hand in hand, if we are going to be putting on Hailguards, as we've suggested, to the kind of designs you've suggested, as an additional, almost like a mandatory additional provision, is to provide spigot outlets wherever possible.
You can't do that with a traditional valley box gutter.
Well, it all depends if
Spigots, I mean.
it's on the outside of the building.
Yeah, if you've got a gutter behind a parapet, yes, you can have the spigots by all means.
Yes.
But if you've got a valley between number of bays of a roof, then you have a problem to do that.
Do the same. You put a super tube exit on the outside of it and it spews out. It doesn't look very nice, but it works like a charm.
Yeah, or you can put a launder underneath. But
yeah, the launder you can also put an overflow box in. We're just doing it on all our roofs. It just makes life a lot.
Good. I look forward to chatting to you afterwards about that. Thank you.
Thanks, David. David, Matthew.
Dennis, I'm just going to handle any of the questions that pop up in the chat. Emmanuel, if I could ask you just if I've missed anything or if there's some comments, I'm going to leave comments to you. Just have a read through the comments and then perhaps summarize and comment on that. So I see that we had a question just from Don Garcia. The 75 kilograms per square meter load on the roof appears very high, or is this only for the cladding design? Dennis, do you want to maybe just comment on that, and then I'll get to Skulk's question as well?
Okay, read 10160 part 2, as I say, it's clause whatever, and that applies if the area that is being considered is less than, I think it's 3 square meters. And then they give you a little formula you can use to reduce it as that area develops from 3 square or 1 square meter to 10 square meters. So it wouldn't apply to a large area. Does that, I hope that answers it for Don.
Okay, great. Don, if you need any further info, just pop your camera on or your mic on and you can ask. Just a question from Skulk. I know, Skulk, that we are going to be covering PV panels in 2 weeks' time. But Dennis, do you want to just maybe just give a quick snippet? Skulk's question is, any comments on PV panel installations posing an increased risk for unexpected hail drift buildup, possibly leading to roof failure?
I don't believe that the risk failure from overloading is any different to a conventional roof, except for the mass of the panels themselves. So it's a minor consideration, but not one you can ignore, depending on your support structure for the PV panel. But we'll discuss that when we talk about PV panel.
Super. Emmanuel, anything that you've picked up in the comments that you'd like to summarize or comment on or note on?
Well, yeah, there's a I think Matthew has another one for Dennis, which is trace heating, essentially melting the hail using some sort of technology under your roof. Do you know anything about this?
That would be extremely expensive.
Yeah.
Very, very expensive.
Yeah.
Whilst the heat transfer through the sheet would be fairly quick, that would be a very expensive way of doing it, because depending on the depth of hail, that heating system will have to be on for 3 or 4 hours.
Yes. Just a comment.
But it would only happen during hailstorms, so you use it once a year.
Yeah, these are very clever systems that are active, not necessarily the best way to engineer buildings to have active systems, because they always fail. That's what we just saw with sprinklers at Joburg Gen. Yeah. But there's another comment, which is just something from my side, because Dennis was talking to David Freem about scuppers and secondary drainage systems. This is something I cover in my course at WITS, in that postgraduate course, which is something we don't cover in our code, relating to the design for ponding of roofs. Typically, we don't do it here because our roofs were never really very big. But now, of course, in the last few years, these warehouse roofs have gotten very big and the slopes have dropped significantly. So this is yet a new area of design for most engineers in our environment here, having to design for ponding. So I do cover it in that warehouse course also, just some methods of how, so ponding from a structural design point of view is a stability problem. And essentially this concept of the water fills up, the thing deflects, and then of course it can carry more water and it deflects more. So it's like a column buckling problem. And I do cover it in these warehouse courses or in that postgraduate course that fits. So just a note on designing roofs for ponding, which is becoming a real issue in South Africa because of the size and very low slope of the roofs.
Yeah, that was one of the things they found in Australia where they had the collapses with that severe hailstorm. And there's quite an interesting paper written by their Institute of, I think it's Consulting Engineers or Civil Engineers, one of their professional bodies, did a whole lot of work on it. And it makes interesting reading because that ponding aspect does come into play. Because the sheet then tends to act as a catenary and hold a lot of water.
Okay, any other questions, please do pop them in the chat. Dennis, what are if no one else has any other questions right now, I'm going to just ask a few. What are some of the common questions, technical questions that have been coming up in the last month or 2 or 3 related to roofing and cladding? It can be broad. It doesn't need to be specifically on Hailguards. If anyone's got questions on Hailguards, please do pop them in the chat. This is kind of just a general discussion. If you've got any questions related to roofing or cladding, now's the time to pop it in the chat as well. But what kind of questions, queries, challenges have come up recently that pop to mind? Dennis?
Well, the most common one every summer when we get a freak hailstorm somewhere is people phone me up and say, I've got a 10-year-old roof or a 20-year-old roof and it's never leaked before. Now we've had a hailstorm and it's leaked. And the bottom line there is the capillary siphon in the side laps. Once they open them up and put some side lap sealant in there, that problem goes away. But that's certainly one. And then, of course, the bimetal corrosion, which is a whole subject on its own, right? And perhaps we present a Q&A answer on that as well, because that is becoming a big problem. And then the installation of PV panels per se on a roof are an issue, and we'll be discussing that in 2 weeks' time.
So Emmanuel brought up the design of warehouse, mentioning that course. I know that you also present a session on that course. What are some of the top things that stick out in your head when it comes to warehouse design and roofing and cladding?
That's another half-hour session.
So what kind of questions come up? I'm whetting the people's appetite for our next sessions.
There's so many things that come up. There's questions about corrosion. Matthew earlier mentioned white death when I think he was intending to refer to white rust. The storage of materials is a big issue on sites. Lifting them into position, trafficking of the roof after it's been installed by other trades. A lot of issues come out of that type of we get questions on that. Questions on fasteners. The durability of fasteners is a big issue. And then the old favorite, of course, is always the design of flashings.
Okay, great.
And penetration through roofs.
If nobody else has any questions, I am just going to let you know while you think of those questions, I'll give you a few minutes to think of anything you'd like to ask. I just wanted to let you know that the Steel Awards will be taking place in 2022, the actual awards events, but the awards are open for nominations between now and the 10th of December. If you've got a project that you'd like to nominate, the forms are available. How we typically handle that is we'll have a Zoom call with the professional team, get the details of the project, and our judges will have a look and see what they think of it. So do go and have a look at the Steel Institute website, nomination forms for Steel Awards 2022. And we'd love to see some of your projects in there. It's a great opportunity to reward excellence in the use of steel in construction. Matthew has a question. Thanks for that, Matthew. He has a question regarding roof temperature and gutter temperature. In other words, how long does it take for hail to melt depending on the surface temperature? Dennis, do you want to take that?
The quick answer is it depends on the color of your cladding, because a dark colored metal cladding with insulation underneath can get to a temperature of 80 degrees C on a hot summer's day. Whereas your gutter, if it's shaded quite a bit by the overhanging cladding, and by definition it's a shaded area, is not going to get much above 40 degrees C. But it depends on the color, depends on the insulation, and it depends on the thickness of the hull, how quickly the temperature is lost.
I understand that. What I'm really aiming at is I've seen some expensive systems that are very interesting, which is a sandwich construction with polyurethane foam, metal below, metal above, typically IBR profile, which means that because it's bonded mechanically and perhaps chemically, the top surface would be a lot warmer even in winter. But I could be wrong, because you have no heat transfer from below. So, let's say the ambient temperature is 4 degrees, okay? And the hail has come down and it's not melting because obviously the air is humid, it's not absorbing moisture, it's very cold, but the roof temperature is, say, 12 degrees. Is that sufficient to get the hail melting at a sufficient rate, or is it going to be a day or two like when the hail's in the garden on the grass?
It'll be solely dependent on the depth of the hail. Because the other thing is too, is that after the hailstorm, if the sun comes out, that hail tends to melt fairly quickly. But steel roofs do not hold heat for a long time.
Yeah, I know. I was just trying to understand something. We haven't really talked about hail on flat roofs. I imagine we have similar problems.
When you say a flat roof?
Well, let's say you've got a concrete roof and you've got a big upstand, and you could collect as much as 0.5 meter of hail.
Yep. Oh yes, from a loading point of view and a clogging up point of view, it's no different. And the flatter the roof, well, a flat roof in South Africa is defined between 5 degrees and 0. Internationally, it's normally 10 degrees or less, and they are very susceptible to drifting and build up. And of course, there in a concrete roof, you've got your full bore outlets, and you need to keep them clean.
Are there Hailguard type systems for full bores? I've never seen one. Is the full bore sufficient? Just the slots in the full bore?
There's a fundamental difference here. Soft roofs are designed for 30 kilograms a square meter, and hard roofs, concrete roofs, are designed for 500 kilograms a square meter.
I'm not worried about the load on the concrete. I'm worried about how it interacts with the full bore. But you're collecting a lot more hail theoretically on a flat roof. So the full bore is now it's waiting for the hail to melt. It could all melt at one point and try and all get through in a little pond, or B, it'll melt slowly, but you still have to protect, I imagine, clogging up the full bore.
Yeah, there's a couple of things, and there's a number of drawbacks when you have full bores, because you can't really develop a good cone to give you good drainage. But on the upside is a flat roof normally has a torch-on type coating to it, which is black and does tend to hold the heat. So that would mitigate partly. But yes, full bore outlets are full bore outlets, and you've got to size them correctly, otherwise you're going to have some problems.
Dennis, just related to that question, do you see a lot of built-up roofs on industrial buildings here? And if so, what's the implication of your details and all your, the past hour of suggestions? And
if you're talking about composite panels, they've come and gone on a sort of a 7 to 10 year cycle since the 1970s. Various companies have tried introducing them, etc., none of which have been successful, largely because there were technical problems with fabricating those kind of panels, and they discovered there was all sorts of chemical problems and reactions between the gases coming off the foam and the underside of the cladding, and things corroded through from the inside out. And then, of course, the main thing is when you have a composite panel is you've got to watch the length, because you're relying on the bond of the glue that is used to bond it to the foam, and some of them, they rely on the chemical reaction that takes place to create that bond. It tends to shear very quickly if you don't get it right, and you get a delamination of the composite panel. But they certainly have been very successful overseas. But from an industrial point of view, from my knowledge and reading, is they tend to go for a composite panel that is made up of what they refer to as a liner sheet, which is the one inside the ceiling, with some insulation in it that is loose, not bonded, and then you have the top sheet on the top, and that accommodates all the differential movement.
Super. If we don't have any other questions, I just want to let you know, those of you that came into the session by a link that a friend sent you, we do have these sessions every week at the moment. Next week, Emmanuel will be presenting as well. If you want to find out more about that, I'm just going to drop the registration link in the chat now. So if you'd like to sign up for notifications for our future technical sessions, that would be where you sign up if you haven't done so already. Emmanuel's topic for next week. Emmanuel, do you remember what it is, or do I need to check the list? It's connections.
No, it's actually, well, let me see. I thought it was purlins.
No, it's connections next week, my
even
friend.
better. Okay, good. So purlins are not for a while.
Yeah, no,
I'll invite Dennis out for that one on purlins, because I think that there will be a lot of cladding associated with the talk on purlins.
Yeah, so also if you've got any questions on specific topics that you are interested in seeing, our recordings of these sessions do generally get posted up onto our YouTube page. We've got a couple of sessions still running through until the 21st of July that we've got our predefined topics. But if there's a question that you have or something that you think would be interesting to have one of these Q&A sessions on, please do pop us a mail. You can send it either to me, which is denise@saisc.co.za, or you can send it through to Dennis or Emmanuel. We've got our technical@saisc.co.za. That's kind of our catch-all for any questions, any technical questions, suggestions. We'd always love to hear from you. Yeah, so that's pretty much it. Dennis, I don't know if you want to say anything in closing off, or if anyone has any further questions, now would be the time to ask them.
Well, if any of the audience have got specific questions pertaining to the installation of PV panels, and the next session is PV panels on existing roofs rather than new roofs, but we will cover both, they're welcome to send them to us so we make sure we address it in the presentation in 2 weeks' time.